Converting a complex number from polar to rectangular form. Let's do the example 5 30 degrees. First thing, we always draw the diagram. So we know that in this case here, well, 30 degrees is the angle we have. So from the positive side of our x-axis or our horizontal axis, 30 degrees. And the length of the segment from the origin to the end where this complex number is 5. So that gives us, if we want to draw on the side here, a right-angled triangle. Angle is 30 degrees here. The hypotenuse is 5. So what we need to find now is this measurement, which is the horizontal projection of that number, which will give us the real part of our complex number, and the vertical, which is equivalent to this. Well, it's the same as that, isn't it? The vertical component of that number, which is the projection on the vertical axis, the imaginary number. So this is all about trigonometry in the right-angled triangle. So what do we want to discover? Well, to get the real part of the number, we need this pink part, which is the adjacent in this triangle, and that is equivalent to the real part of the number, which is a. So if we think about hypotenuse, adjacent, that leads us into using cosine. So all we need to do here is use cosine of 30 degrees equals adjacent, which in this case is that a, over the hypotenuse 5. Solve this equation for a, remove the 5 from there, multiply both sides by 5, so 5 multiplied by cosine of 30 degrees. And then we can do this calculation if we want. So 5 times cosine of 30 degrees in one go. I'll round it to one decimal place, 4.3. So 4.3 is the real part of this complex number that we are converting into rectangular form. And then we do the same thing to discover b, the vertical component, the imaginary part of the number. So b in this case is the opposite to the angle of 30 degrees. And we also have the hypotenuse. So that leads us into sine for so. So we could say sine of 30 degrees is the opposite, in this case b, over the hypotenuse 5. To solve the equation for b, we multiply both sides by 5, so b equals 5 sine of 30 degrees. We do the calculation, 5 times sine of 30 degrees, 5 times a half will be 2.5. So 2.5 is the imaginary part of this complex number in rectangular form. All we need to do now is say that 5 30 degrees in polar form is equivalent to a, 4.3, plus b is 2.5, 2.5, j. We tend to write j at the front sometimes, so we could do this here too. So it doesn't matter which way, but j 2.5. That's the equivalent rectangular form for that original polar form of this complex number. And double check that in the diagram 4.3 is a positive number for the real part, so it would be somewhere there, let's say 4.3, and 2.5 is also a positive number for the imaginary, so 2.5 is here, and they both connect to give us that point with an angle, positive angle less than 90 degrees, and modulus 5.